Yeah, we have learned how to write subclasses all the while now. I'll finish it off now. So see, all the while, all these days what we have learned is how to write subclasses and how to work with subclasses. Okay, so how to write subclasses, you know, no? You will have a class, and if you want any extra modification, if you want any modification into this class, what will you do? Void m1 SOP inside m1 SOP value of x and y, like this. One class will be there, assuming that one class will be there. Okay, so now if I want extra members, that is modification of extra members is nothing but modification. That is when you write subclasses. Clearly get this point now. I am summarizing it. See, if you want to, we are learning here how to write subclass now. Just get the point now. How do you write a subclass? By extending. Extends A, correct? So you write a subclass like this. That's when this becomes a subclass. Now why do you write a subclass? To modify existing classes or to inherit the functionality of one class into another class. Getting it now? Are you clear with this one? Fine. So once you do this, you can add your extra member. See, we are learning here. Here I am teaching you how to write subclasses. Int z void m2 SOP value of z is. So this is only modification. I wanted an extra variable and extra method inside that class, but I decided not to modify it there, and I wrote a subclass. Understood how to write subclass? So when you write a subclass, you will add variables. If you write variables, you can add constructors also to initialize, and after that you go on writing methods. You know how to write methods also now. What methods you'll write? You know, new method, overridden method, overloaded method, anything you can do. Apart from that, you can write blocks also. That also you know. So once you write a subclass, next what you do? You use it. Once you write a subclass, next what will you do? You use it. Carefully see now what we do. Class demo PSVM. Now using the subclass is becoming important. Using the subclass. So first I'll teach you how to use the superclass. A is equal to new A. So which class am I using now? Class A. What is class A? Superclass. So now a superclass object gets created. What are the members? X, Y, M1 are the members. This is A object. Valid. So I created an object of superclass. So you know how to work with it. So here I am working with the superclass object, and to work with the superclass object I am using what? Superclass variable. Yes. So here means the default values of x and y are 0. See how I am working. A dot x is equal to 10. A dot y is equal to 20. A dot m1. I can call the method. Yes or no? So we are working with the members now. Yes, you know how to work with superclass now? Yes. Now pay attention. Let's see how to work with subclass. All this you know. Understood? So let's see how to work with subclass. See, I want to work with subclass means I have to create object of what? Subclass. New B I have to do. But if I want to work with the object, I have to hold the address. So what will I do now? Till now we were doing this. BB is equal to new B. Means we were creating subclass object, and we were creating subclass object, and we were initial means giving the reference value to subclass variable. Yes. So when you create a subclass object, you can give that reference to a subclass variable. Yes or no? You are giving till now. Okay, so once you give it, now you can work. See here, b dot x is equal to 5, b dot y is equal to 6, b dot z is equal to 7. So again x is 5, y is 6. Initially there will be 0. Now there will be overwritten to this. But notice we are working with all the members. Yes or no? So when you create a subclass object, you can refer to that object with the help of what? Subclass variable. Means subclass variable is referring to subclass object. Till you are clear now? Only change what I will do now is, if at all you want to work with, now this is a new case now, what I am taking. If at all you want, this is case number 1. See the case number 2 now. If at all I want to work with subclass object, I can use a superclass variable also. This is valid. So you can work with your subclass object using two variables. One is superclass variable, the other one is subclass variable. Getting this point now? But the difference will be what? If I do the coding like this, now problem is I can work with only superclass members. That's all. Understood? You can work. Okay, now A is equal to new B. So for this code, what will happen now? B object is created, X is there, Y is there, M1 is there. Leave these two now. These two you leave. Concentrate on only this now. This case is one case. Leave this. I am concentrating on the case 2 now. Understood? So A is equal to new B when I say you are having X, Y, M, Z, M2. All the members are there. But problem is, okay, I am referring this object. B object is referred by which one now? A variable, superclass variable. It is possible. 100% it is possible to work with subclass objects. Now I can use subclass reference variables or I can use superclass reference variables. Any variable I can use. See, here is a good example. To work with subclass object I am using subclass reference variable. Now here to work with subclass object I am using superclass reference variable. Valid. 100% valid. But here we have a problem. What is the problem? If you want to work with subclass members, it is not possible. You can't work with subclass members. Means A dot X is valid. I'll give 11. A dot Y is valid. 12. A dot Z is equal to 13. Error. I cannot work with the subclass member. Are you getting it? Similarly, A dot M1 I can call. I can call the method. A dot M1 I can invoke the method. A dot M2. No, this is not possible. Huh? Are you clear with this? Are you clear with this?
So what if the...
Wait. Okay, are you clear with this? Clear? Any questions you are having here? A superclass reference variable can refer to subclass object. That's what I framed yesterday on statement. What did I frame yesterday? A superclass reference variable can refer to subclass object. But what members can be accessed depends on the type of reference variable. Depends on the type of reference variable. Generally we tell that. Okay. Means if it is of B type, I can access all the members of B. If it is of A type, I can access all the members of A. Are you clear with the case 1 and case 2? Are you clear with the case 1 and case 2? What is case 1? Subclass variable referring to subclass object. What is case 2? Superclass variable referring to subclass object. Understood? Are you clear with this? But one more condition I will take. What? Subclass variable referring to superclass object. That is not possible. Ulta. Subclass variable referring to superclass object is not possible. This is valid. All these points are clear now. Take the case number 3 now. What is case number 3? BB is equal to new A is invalid. You cannot create superclass object and give that. See, this is case number 3. I'll write it here. The case number 3 now. This is case number 1. Sorry, I made a... This is case number 2 now. Okay. See, this is case number 2. This is case number 1. Clear? So, one should go that side. See, case number 1, this is the case. Case number 2, I written it here. Now let's see case number 3. Which one? BB is equal to new A. Actually, which object you have created here? A, X, Y, M1. We have created superclass object. Now how is it possible to give it to B? Not possible. Clear? So subclass reference variable cannot refer to superclass object. So you should know how to work with these two variables and objects, classes. You have got 3 things here. Combination you should understand. One is variable. Second one is class. Third one is object. Understood? So you will declare a variable of a class type and that variable will refer to the object. You will declare a variable of class type A. You are declaring variable of class type and that variable will be used to refer to an object. All these statements should be clear now. Reference variable, class, object. I am using those terms extensively now. I am using those terms extensively. Reference variable, class, object. Are you clear? Any questions? So subclass variable cannot refer to superclass object. Clear? Clear this? This is a very, very important subject of Java. It's a very important subject. You don't know how important it is. Understood? So anyway, we'll be seeing how important it is. Slowly it will start off. Okay. Shall I clear all? Okay. Similarly, we'll see some more things here. See, this is one way of seeing it. Yesterday I have explained you the same concept. Yes or no? Clear this? Any questions? You know what is a subclass? Now we are learning what? How to work with the subclass. How to work with the subclass means what? creating object. You create object and you work with the object. When you create the object, to work with the object you have to store what? The reference of that object into a variable. Either you use same type of variable or you use superclass type of variable. That's all. Now all of you right now think the best is what? This only. BB is equal to new B is only best. Why you will tell? Because I can access all members, obviously. And you'll be thinking, no, this is a silly thing. Why did they do this? This is very powerful. And this is what will lead into dynamic polymorphism. We are moving to the next subject called as dynamic polymorphism. Are you getting it? Clear with this subject? You have any questions here, you ask. Clear? Some more. Same thing I'll do ulta pulta, but let's see. See, we are having A is equal to new B. Just I'll make some changes here itself. So leave all these cases now. I'll just make changes here itself. So see this now. A is equal to new A, B is equal to new B. Here also you can see. A is equal to B. Valid or not? Huh? A is equal to B is? Means A will refer to which object now? See, earlier A was referring to, see here, let us revisit the same. These markers are not right here. Okay, so now see, we have created a object and we are referring it with A. We have created a B object, referring it with B. All this is okay, you understood this. If I write A is equal to B, valid now? The address of B is given to what? A. Means A was earlier referring to this object, now it will refer to this object. Correct now? This is dereferenced. Okay, this is dereferenced. And these values are 10 and 20 now. Okay, earlier if you print A.x, what it will print? 10 and 20. But now if you print, what it will print? 5, 6. Are you clear? Are you clear this? Okay. So A means on what grounds you are telling it will work? Because a superclass variable can refer to subclass object. But this is working, correct. But B is equal to A is error. Why? Because subclass variable cannot refer to superclass object. This will get dereferenced. Okay, but the thing is subclass variable cannot refer to superclass object, and this error is reported when? Compilation time. Why they are reporting at compilation time? Because by chance if it refers, during runtime you will try to call the method no, b dot whatever I try to access, z and m2, but it is not there in this object. You understood why is subclass variable cannot refer to superclass object? Because in superclass object you will not have subclass members. In superclass object you will not have subclass members. That is why subclass variable cannot refer to superclass object. But superclass variable can refer to subclass object because at least you are having superclass members here. Yes, you can access all that. Clear this concept now? Till now any questions? Okay, fine. So now if you understood this, next we will see the next topic. Yes, now we will compare the two data types, class and subclass. What it is, two data types. In fact, Java is having 4, but we will see the difference between a class and a subclass. So this is how you have to define what are subclasses in the interview. What is means generally you say what is a class means class is class. What is subclass means subclass is subclass. What is there? They are not answers. See the answers now, how they come up. So Java actually has 4. We have completed 2. Okay. Java has 4 user-defined data types for implementing OOPs. Okay. First one, class data type. It is a user-defined data type which can be used for implementing OOPs generally. Understood? So then it is used when we want to write new concrete implementations. New concrete implementations. Understood? Now what is a subclass data type? Means when do you use a subclass data type? Okay. Or what it is. All we are covering now. So it is a user-defined data type which can be used for what? Implementing OOPs. It is also a more user-defined data type which can be used for implementing OOPs. But when is it used? See here. It is used for doing inheritance or inheriting the functionality of one class into another class. This is one more way to define it. There are many answers. See this. It is used for adding or changing implementation for existing classes. One more answer. It is used for modification of existing classes. One more answer. It is used for specialization. Subclasses are used for what? Doing specialization. Whereas superclass will be used for generalization. Getting it? Now it is also used for doing what? Inheritance. You will tell what is subclass. Subclass is used for doing inheritance. But apart from that, these many answers are there. Clear? Now next one. One more last point from the design point of view. Design principles we say. From that point of view, it is used for establishing a relationship between classes. Is a relationship. Are you clear with this? Is a relationship. So this is what you have to tell in the interview. What is the difference between a class and subclass? These many answers are there. Okay, you can tell anything now. After that, he'll tell, write some program, this and all. That story starts next. But these are your answers for difference between class and subclass. Do you have any questions here? All points you understood?
What is new concrete implementation?
I have told you now how many times to tell. New concrete implementation means code is there. You are not happy with the code. Full code I want new, right? Classes are used for doing what? New concrete means some code is there. If it is, see, first of all, if I ask you to write some code, you should not write. First you should see whether it is there. If it is there, directly create object, use it. If it is not there, means some code is there already, but what you require, it is not there. So that is when you write new classes. Some classes are there, but you are not happy with the existing thing. That is when we write new classes. So that is called as class. But sometimes what will happen? Class will be there. You want to modify it. That is when we write subclass. So this is how you choose the data types. Classes are used for doing new concrete. Concrete means we'll see what is concrete later. But new implementations. Classes are used for doing new implementations. The concrete word now you will not understand. Later on only you will understand. Clear? So when we complete other two data types, which one? Abstract class and interface, then you will understand this. So clear? Clear this? Yes sir. So hold this then. Yeah. Put the heading as dynamic polymorphism now. Put the heading as, yeah, now we are entering dynamic polymorphism. Dynamic polymorphism. See, we saw till now what we have covered is subclasses. We saw subclasses, and then we saw overriding. We saw overriding. We are very comfortable with overriding now. Yes or no? What is the criteria for overriding? Object. So which object you create, method from that class gets executed. Preference is given to the local one. If not, super. You know this story, no? So the criteria for overriding becomes object. Criteria for overriding becomes object. But let's see what is. Now we are going to dynamic polymorphism. Let's see what it is. Okay, there are two classes. M1, sorry, there is one class, there are two methods. One is M1, the other one is fun. Now let's see what I'll do. I'll write class B extends A. Very important subject, huh? Void M2. So M2 means class B decides to inherit all the functionality of A, but to add one new functionality, that time you are writing M2. Then class B is also deciding to change the functionality of what? Fun. it will override. So it will add one M2 method and it will write fun method. You understanding now why I am writing M2 now? Because I want a new logic. So I will write a new method. But I don't want the logic of fun in class A. So when you write a class, subclass now, think logically and write. Why did I write a subclass? I wanted the logic of M1 in A. And I wanted new logic. I wrote M2. But I don't want the logic of fun in A. So I will override. Understood how these two methods come out now? So what is happening now? Class B is extending A. Clear? So we are overriding. We are overriding. Okay, fine. Now clearly understand this concept now. See, A is equal to new A. Which object is created? Superclass object. It is referred by which variable? Superclass variable. Always you should see both. So superclass object is created. What are the members? M1 fun. This is A object. Clear? Now next we'll say BB is equal to new B. Which object is created? Subclass. Means what are the members? M1 fun, M2 fun. I was telling you criteria for overriding is what? Object. Clearly see this now. A dot fun. Which method gets executed? The one in A class. There is no conflict there. Blindly it will execute. In A you don't have any problem. But when I say A dot M1 also fine. These two no problem. You don't have any problems. But B dot M1, how it executes? First it checks in bottom class. Not found. From where it will execute? Superclass. B dot M2. Again what happens? Checks in subclass. Not found. Executes from superclass. Done? Sorry. B dot M2 is in subclass. It will execute from there itself. So you understood how M1 works, how M2 works. Now the important thing is fun. B dot fun. There are two funs, but preference is given to local one. Correct only. That is what I want to execute. I am overriding because I don't want the logic of class A to execute. If you don't want the logic of class A to execute, that is why you have created which object? B object. Done now? Are you clear with this? Yes. This also okay. Now I am going to the topic of dynamic polymorphism. Here it starts. Here it starts. Understood? This is the beginning. This is the beginning. You will take some time to understand. Dynamic polymorphism is one of the big concept of OOPS. Understood? Let's see how Java tries to support dynamic polymorphism. Don't think dynamic polymorphism is a feature of Java. Dynamic polymorphism is a feature of OOPS. Let us see how that is achieved in Java now. Yes, leave these two things. Now we'll go to a new coding now. A is equal to new B. You know this formula now. Is it valid? Is this valid? On what grounds it is valid? A superclass variable can refer to subclass object, you know that. So we'll concentrate on this line. Superclass variable can refer to subclass object. Yes. So what object is getting created? You don't bother about this now, forget it, you know everything about this. Concentrate on this case now. So new B, we are having what? M1 fun. These are members of class A. Yes or no? But you have created new B. What are the members? M2 fun. So it is referred by which object? Sorry, which is referred by which variable? Superclass variable. Valid, perfectly valid. No doubt. So superclass variable can refer to subclass object. But what members can be accessed from the object depends upon the type of variable. Yes? So now see. A dot M1. Can I access or not? Compiler will compile. Understood? Compiler will compile it. And it will, during runtime, it will execute. And why it will compile? Because you can access M1 with A. It will compile. Done? And you will get the output. During runtime, you will get the output as, it will execute from here only. No issue. A dot M2. What will happen? Error. Because superclass variable is referring to subclass object. Superclass variable is referring to subclass object, and superclass cannot access subclass member. You know that very well now. Clear with this? So this is error. No, a dot fun is the question. Which method gets executed? The subclass method gets executed. Here, the method from subclass is getting executed now, not superclass. Understood? So actually you are thinking what? It will compile. But during runtime, it will be picking the method from subclass. Understood? So now see, forget now a dot fun. Forget a dot fun. First let's come to this object. Which object is this? B object, subclass object. Okay, when you create the subclass object, okay, you call the overridden with method with any variable, irrespective. You call it with superclass variable or you call it with subclass variable. It will always search the methods in bottom. Local. Understood? It is correct only, there is no confusion. You might be thinking why it is not calling from superclass, or because I had given you a statement before. What is the statement I had given before? A superclass variable can refer to subclass object. What members can be accessed from the object depends on the type of variable. You are holding that now. That is correct. I am not telling no, 100% valid it is. But there is an extra condition for it. The condition is, if methods are overridden, it will not be depending on the variable. Means I am now contradicting. Yesterday I was telling it was depending on the variable. What members can be accessed from the object, I was telling it was depending on the variable yesterday. Now I am contradicting. Now I am telling what? It is not depending on the variable, it is depending on the object. So you should know how it works now. So see, what members can be accessed? Yes, it continues. It depends on the type of variable itself. Which member gets accessed depends on the type of object. What member gets, means what members can be accessed. See this point. This is very crucial point now, because many times, see, if subclass variable refers to subclass object, no issue. But if superclass variable refers to subclass object, all this story will come. Okay. See, what members can be accessed, these two important points you should know, depends on what? Variable type. What members can be accessed depends on the type of variable. Okay, or the type of variable. Means whether it is superclass or same class, that depends. Okay, but see this next point. Which member gets accessed depends upon the type of object. And it is correct, 100% valid. Understood? Now if you ask me, say I created which object first of all? Subclass object. What was my intention of creating subclass object? Because I wanted the code from subclass to execute. Yes or no? Your intention of creating subclass object is what? You wanted the code from subclass to be executed. So I created the subclass object. Now just because I changed the variable name, means I am referring to it superclass, should it execute from superclass? No. When you have created subclass object, your sole intention is to execute the logic from subclass itself. Now you refer it from superclass or subclass, why you should bother? It will definitely execute it from subclass only. This is the beginning. Okay, this is the beginning of dynamic polymorphism. Dynamic polymorphism means, see this one only. Okay, what members can be accessed depends on what? Type of variable. Which member means which method to execute is decided at the last moment. During execution it says, okay, it is referring to B object. Now execute from B. Are you understanding now? So in overriding this happens. So this is wrong only, as I told you it is correct. A superclass variable can refer to subclass object. What members can be accessed from subclass object depends on the type of variable, correct. Now you cannot access M2. But if methods are overridden, only the condition is that if methods are overridden, it depends upon the object the variable is referring to. A is referring to which object? B object, no, it will execute from B. A is referring to which object? B. So when methods are overridden, it depends upon the object the variable is referring to. Means A is referring to which object? B object. It will execute from that place. Are you getting clear with this? This is the most important point of Java now. Okay, so why they are made like this? You start understanding. What is that? See, yesterday I told you, I gave an introduction. I told you superclass variable can refer to subclass object. What is the advantage of it? I told you there are 3 or 4. I told decoupling, dynamic polymorphism. Then high level of abstraction. 3 points I gave you. If a superclass reference variable refers to subclass object, there are 3 great advantages. One is decoupling, second one is high level of abstraction, and one more is dynamic polymorphism. I am introducing that only one by one. All the 3 points I have to cover, then you will understand all this. So right now I am introducing you dynamic polymorphism. Are you clear with this? Okay. One more. By chance, if I write, here only I will write class C extends A now. It is hierarchical. Don't confuse. It is hierarchical. Both B and C are extending what? A. So C will have some method like M3 plus, okay, first I will write off, okay, M3 method. So C is having one M3 method plus it is having one more fun method like SOP inside C fun. If you want to put on SOP in M3 also, SOP inside C M3, that's up to you. Class C is extending A now. Now very interesting again, if I write, okay, I'll write it here. A is equal to new C. Which object I am creating now? C object. So the C object is getting created now. See here. What are the members of C object? M1 fun. M1 and fun from superclass. M3 and fun from subclass. Because see, it is an object of C. It will have only A class members and C class members. It will not have B class members now because it is hierarchical. See the hierarchy. B is also extending A, C is also extending A. So now if you say this, see now, A dot M1, can I access? Yes. So C dot M1, yes, compiler will compile and during runtime it checks in subclass only first. During runtime it will check from subclass. If it is not found, it will be executing from superclass. Methods are always searched from the bottom only. Okay, A dot M2 error. Sorry, A dot M3. Means with superclass you can't access subclass member. But A dot fun, it will execute from subclass. See, M1 it is executing from superclass. Fun it is executing from subclass again. Means which method gets executed depends on what? The type of object, not on the type of variable. Which member, I am telling you, which member gets access depends on the type of object. What members can be accessed depends on the type of variable. Both the rules are correct. Understood? So this will be checked by compiler. This will be checked by, here compiler will play a role. Here JVM will play a role. So JVM will decide during runtime which one to execute. Okay, it will start looking from the bottom now. Are you clear with this? Compiler checks what members can be accessed. JVM checks which one to be accessed. Understood? Which member to be accessed is checked by JVM. What members to be accessed is checked by compiler. Are you clear with this? So, see, again I am repeating the statement. Okay, one extra point is added today. Yesterday's point is continuing. I am not defying it. It is correct. But I am adding one more extra point to it. Carefully observe the point. I will first repeat it from the beginning. A superclass reference variable can refer to subclass object. A superclass reference variable can refer to subclass object. But what members can be accessed from the object depends on the type of superclass reference variable. Correct? If the methods are overridden, now it depends on the type of object the superclass variable is referring to. It depends on the type of object the superclass of variable is referring to. Means A is referring to which object? B. From B it will execute. A is equal to C. Means it will execute from C object. It depends on the type of object superclass variable is referring to. If it refers to B, it will execute from B. If it refers to C, it will execute from C. It depends on the type of object. Are you clear with this concept? This itself is called as dynamic polymorphism. Understood? This is just the introduction. Still, definitely you'll ask me what is the advantage of this. Understood? We'll be saying this in a short while. Are you clear with this concept? Are you clear with this? Shall I clear everything what I have written? Some more changes I'll do. Same program I'll take and I'll make some more changes now. Shall I clear everything what I have written? Clear this? What members can be accessed depends on the type of variable. Which member gets access depends on the type of object. That's why I'm repeating this from past 3-4 days. Very important statement. Clear? Shall I clear? Shall I clear? Same program, we'll see some more things. Just I'll make some small changes. See, A is equal to new A, B is equal to new B, C is equal to new C. I am creating three objects. Which are the three objects I created? A, B, C. So A object, when it is created, it will have M1 and fun. Any questions here? This is an object of type A. B is equal to new B. An object of what is created? B. See, this class is having only A class members. A object is having only what members? A class members. Now when you create B object, it will have two class members. One is A class, other one is B class. What are the members of A? M1 and fun. What are the members of B? M2 and fun. So this is B object. Valid? C is equal to new C. So what happens? Which object is created this time? C object. What are the members? Members of A and C. Means M1 you will have as it is, fun you will have. And in C class members you will have M3 and fun. So this is C object. Do you have any questions till here? I have created three objects, A, B, C. Normal it is. So and if you see again carefully, we have created superclass object and we are referring it with superclass type of variable. Understood? We have created B object. We are referring it with subclass object. We are referring it with subclass type of variable. Means same. Subclass variable referring to subclass object. We have created C object. We are referring it with C. Means subclass variable is again referring to subclass object. Always you should see both. Object also you should see. Variable also you should see. You should be very cautious. Understood? Because what members can be accessed from the object depends always on the type of variable. This is a very crucial point now. Understood? Now let's see how to work with all the three. See, A dot M1, can I access? Yes. A dot M2, sorry, A dot fun. Only two members I can access. Yes or no? A dot M1 and A dot. See, from A you can work with all these members. A dot M1, valid. A dot fun, you can access. This is from A. Now let's see from B. B I can access what? B dot M1. But see, in B only it starts. 1 second. See, with A, I'll try to access some members in class A now. I'll classify it. A dot M1. Can I access? Yes. It will execute. A dot fun. Can I access? Yes. In superclass, you don't have any difficulty. Working with superclass or class is same. But when we work with subclasses, stories are different. So now from class B, I'll work. B dot M1. Can I access? Yes. Which one gets accessed? Checks in subclass, doesn't find, executes from superclass. So preference is always given to the object only. You access the method from any variable, subclass variable or superclass variable. It will always check from bottom only. B dot M2, can I access? Yes. Again preference is given to subclass. B dot fun, can I access? Yes. Again preference is given locally, it executes that. So it means here it prints from inside B only. Yes or no? Here it is printing inside B. Here it is printing inside A. Now let's see with C object what happens. C dot M1, can I access? Yes. C dot M2, can I access? No, it's not there. Sorry. C dot M3, can I access? Yes. Means how it works? Checks in the bottom, finds, executes. M1 it will check in the bottom, not found, it will execute from superclass. M3 checks in subclass, finds, executes. Same C dot fun. From where it will print? Inside C, it will print from subclass only. Are you getting the clarity between these three things? Are you getting the clarity? Inside A, inside B, inside C it prints because you are overriding it. Understood? Yes. Now we'll do a small change. You answer me this now. I'll have a variable A, Z. So what is this now? Z is a variable of type A. Valid? Z is a variable of type A. Now Z dot M1, can it execute?
Yes.
How it will execute? You don't have to work with the object only. Z is a variable, it is not referring to any object. First let it refer, now initialize it. Understood? First initialize it. Till now you have completed so many classes of Java, you don't know how to work with variables. So this gives you error. So fine. So it is not initialized. Now I'll initialize. Start seeing how I initialize. A, Z. Valid? See, Z is equal to A. What did I do now? The value of A is given to Z. What is the value of A? It might be some address. You are giving the reference value of A to Z. A is this reference value. You give it to Z. Now it is ready. Now Z refers to what? A object. Now see this. Z dot M1. Will it execute? Yes. Leave M1. We are more concerned about fun. Z dot fun executes. From here it will execute A. Now see this. I will say next condition. Z is equal to B. Now what will happen? Z, the value of B is given to Z now. Understood? See here the condition is superclass variable is referring to superclass object. See that first. A is superclass object. A is a reference value of what? Superclass object. The reference value of superclass you give it to Z, which is a superclass variable. So superclass variable is referring to superclass object. I can access all the members. But here what is happening? Z is equal to B. Superclass variable is referring to subclass object. B is a reference value of subclass object. B is a reference value of subclass object. Understood? So when B is a reference value of subclass object, you are giving that reference value to superclass variable. Valid. Now Z refers to this. What it will refer? B object. If you want to check out, print the address and see, it will be printing B's address. But story is, if I say Z dot M1, can I access? Yes. Z dot M2, can I access? No. You cannot access. But Z dot fun, it will print from what? Subclass. Criteria for overriding is always object. Do not look at the variables. Let superclass refer to it or let subclass refer to it. Don't say it. Criteria for overriding is always object. Correct only. Why did you create subclass object? For your code to execute. Now just because you change variables, it should not execute from superclass. No. The whole and sole intention of creating subclass object is to execute our code. Okay. Now you change of the variable, it starts executing from superclass. It's dangerous. No. So it's not at all confusing. Just stick on. Criteria for overriding is what? Object. Just stick on. If you change of the variable, it will not execute from superclass now. Understood? That's what they say. What members can be accessed depends on the type of variable. Which member gets accessed depends on the type of object. See now. So Z is referring to which object? B object. That is why Z dot fun is getting executed from subclass. Which one? B class. Which member gets access depends on the type of object. Now another condition. Z is equal to C. Valid. Again, what is the condition? You are giving the reference value of C. But C is having a reference value of which object? Subclass object. So again, what is happening here? Superclass variable is referring to subclass object only. Here, see, here superclass variable is referring to superclass object. Here superclass variable is referring to subclass object. Here also superclass variable is referring to subclass object. Fine. Now Z dot M1, it will execute. Z dot M3, error, you can't access. So Z dot fun, it will execute. Now Z is referring to which object? C object. The same variable will refer to this. So it will execute from C class. Brilliant it is. So as it goes on changing now, okay, if it refers to A, it will execute from A. If it refers to B, it will execute from A. If it refers to C, it will execute from C. Understood? This is dynamic polymorphism. Which method to execute is decided at runtime. I will explain you that very clearly. Which method is executed is decided at runtime. Understood? It cannot be decided at compilation time. I'll explain that point to you. Which member to be accessed is getting decided at runtime. I'll explain you that point too. Okay. So are you clear with this? See here the output would be inside A. Here no issues for you. This is the output. Here the output would be inside B. But here it will be inside C. But it clearly shows Z variable is referring to which subclass object, from there it is getting executed. You are not getting a standard output. Z dot, see here Z dot fun means it will print inside B. Here if you say Z dot fun means it will print inside C. You are not getting a standard output. So depending on the object, it will be executing. Okay, now let's understand what is the difference between compile time polymorphism and runtime polymorphism. Yeah, see this, assume that, okay, all this code is okay, you know this, but assume means I think that I have written line by line only. After these 3 lines I have written these 2 lines, after these 2 lines I have written this, after that I have written this, think like that now. After that I have written this, after this I have written that, like that you think now. Okay, so first see now, when you compile, compiler will compile, but when the compiler is compiling, can it decide that during runtime it will call which one? It is unable. See, when you compile, no objects are not created. Remember that. When you compile, only source code is converted to byte code. But only when you during runtime the objects are created. Always, when you run the program, objects are created. Remember this. So that is why, okay, see here, z is equal to a, z dot fun execute from a, z is equal to b, z dot fun execute from b, z is equal to c. As the program goes on executing, last moment here, neck moment, it will decide what to execute. Z dot fun, okay, it will execute from a object. Z dot fun, okay, it will execute from b object. Z is equal to z, z dot fun execute from c object. Next moment, last moment, it will decide, okay, which method to execute from which object. Last, when the line comes to execution, that is when it is decided. Till then it is undecided. But overloading is not like that. Overloading is happening at compilation time. So overloading is happening at compilation time. Okay, so if you want to do compile time polymorphism, we do method overloading. If you want to achieve runtime polymorphism, we do method overriding. Understood? So this is how it stands. I'll give more examples on this, but this is how it stands. Okay, so is this statement clear to you now? What members can be accessed from depends on the type of variable. Which member gets accessed depend on the type of object, not on the type of what? Variable, reference variable. It's very crucial. It is not depending on the type of reference variable. If it was depending on the type of reference variable, what would have happened? Everywhere it would have executed what? Inside a, inside a, inside a. It is not depending on the type of variable. It is purely depending on the type of object. Are you clear? Are you clear with this? Shall I clear all this? Okay. Now we'll see what is the advantage of this. You understood what it is. Now, what is the advantage of this? You will question now. You understood? Means dynamic polymorphism, how it works you understood. But what is the advantage of this now? Next question. Shall I clear all this now? Okay. Same program, see the advantage. Same program, see the advantage now. See now, just let's take only A class, only A variable. There is one variable called as A now. Okay, A is equal to new B, I will say. What did I do? Which formula I used? Superclass variable referring to subclass object. If I do this, now B object is created and that is referring to which one? An object of type B. Yes? Okay, now A dot M1 it will execute from superclass, A dot fun it will execute from subclass. Yes or no? So here it prints inside A. But tomorrow I feel I do not want the output, means I do not want to use A object. I feel that implementation, I do not want to work with B object. Tomorrow I feel that implementation is bad in B. I want to use the logic of what? C. One change what I'll do is, that's it. This is decoupling. Tomorrow you can change your implementation by writing what? Just new C, that's all. One small change you do now which object is created now? C object is created. When you run the program, C object is created and A will refer to this. So if you want, you can change the implementation. Now see, this is the great advantage of what? Superclass variable referring to subclass object. But if I had coded like this, other way, BB is equal to new B. Understood? B dot M1. Then I will say B dot fun. If I have written this code, fine, it will execute. But tomorrow I don't want the logic of B. What all changes I have to do? Fully you have to change. What you have to change? Remove all this and say C is equal to new C and tell C dot M1 C dot fun. Now see, managing your code is becoming difficult. You have to, means maintenance becomes a headache. So that is when what we do, instead of taking this approach, I start using what? Superclass variable referring to subclass object. If you want the logic of C, create the object of C. Tomorrow you don't want the logic of C, you just say B, anything. B also you can tell. Now which logic gets executed? Sorry, A.fun it was printing. Now it will print inside B. A.fun now it will print inside B. A is equal to new C, which logic it will print now? Inside C. See how easy it is to change. You can have one more class. Class D extends A. I want D logic. Change. But here nothing is changing now. Understood? But here you have to change everything. B is equal to new B means you have to change. C is equal to new C. All that you have to change. Understood? So you have to decide. See, sometimes it will be very sure that you want the same implementation. That's the question now. Okay, which is best now? Whether to use superclass variable to refer to subclass object, or whether to use subclass variable to refer to subclass object. If you use subclass variable to refer to subclass object, the problem is tight coupling. You are tightly coupled. Understood? Means tomorrow you don't want the logic of B. You want to use the logic of C. This will not work. Will it work? B is equal to new C will work. The condition is what? Provided C extends B, it will work. But that is not true now. Hierarchical. This would have been true provided C was extending B, but we are dealing with hierarchical today. So in multi-level it will work, but not in hierarchical. So this becomes a headache. That is why you are supposed to change the full code like this. What? So when you create subclass variable refers to subclass object, it is tight coupling. Means if you want to modify anything, full code you have to change. Understood? Here also you have to change C, here also you have to change. If you don't want C implementation, you have to write the logic of B. But if I do this, I am loosely coupled. So which code you want? Simply you will change it here. New B or new C or new D, you decide. As simple as this. So it is up to the developer. Developer is having this option. Developer is given this option. What option? You want dynamic polymorphism support, then what you do? Or use superclass variable to refer to subclass object. Now which subclass object is created, that method is executed from that subclass object. If you want the support of dynamic polymorphism, okay, use superclass variable to refer to subclass object. Now which subclass object gets created, the method gets executed from that variable. Sorry, that object. I'm repeating it. If you want dynamic polymorphism support, use superclass variable to refer to subclass object. Now which subclass object is created, the method from that particular object gets executed. So this is decoupling. So tomorrow it will help you to change your logics. So developer is having an option. Okay, see, if you want loose coupling, do this. But sometimes you will need tight coupling also. Sometimes. That time you go for this support. And if you do this, you have an extra advantage. What is that? You can call subclass member also. Yes or no? That advantage is there. If you do this, one extra advantage is you can call the subclass member. But here can I call the subclass member? A.M2 is error. A.M3 is error. Can I call them? But here I can call B is equal to new B. I can access subclass member. So there is advantage and disadvantage of both. Only you have to decide how you want the solution. And this is what is achieving high level of abstraction. High level of abstraction means what? There will be so many subclasses like this now. A, B, C, D. You can go on. Many people will write subclasses. Okay, they will write subclass. Now tomorrow you want to use. What will you do? You just change here. That's all. New C. Now you are working with whose object? Somebody's object. You are getting the output now. What is that called as now? Abstraction. You don't know how you are getting the output, but still you are getting the output. You are not happy with that person's class. Somebody else has written a better logic. What will you do? Change it to D. Now what is happening? You are working with his object now. You are getting the output now. Why are you bothered? That itself is abstraction. Understood? So here what happens is, if you want to achieve high level of abstraction, you can do this. Very high level of abstraction. Okay. So gradually we will be using this in a very extensible way. Okay, this is the beginning of dynamic polymorphism. Throughout our programming life, we'll be doing this only. So it will become very, very clear to you. You don't have to worry about this. Overriding is a big subject. Clear? It is not as simple as you're thinking. How many days I'm teaching you overriding? 3 days over already. Understood? Still it will continue overriding. Minimum I require 7 more days to complete what? Overriding. That huge topic it is. Clear? Only on 10 days we spend time on what? Overriding. Fully. That huge it is. Clear? Are you clear this? But concepts will become clear with more examples. Here I introduce concept. In one program you'll understand some concept. Next program you'll understand some other concept. Next program you'll understand some other concept. Like this it goes on. Clear? Any questions here? Any questions? No questions? So this is where Java starts off, and this is one of the brilliant feature of what? Java, and this is how it supports dynamic polymorphism. And this itself is called as dynamic method dispatch. One more word they use. Dynamic method dispatch can be used, can be referred to previous example. Just I'll bring it back now. Shall I clear this? Now what is dynamic method dispatch? That also I'll explain. You understand what is decoupling now? Yeah. Supposingly, yes, the previous program you see just A is equal to new A, B is equal to new B, A is equal to new A, B is equal to new B, C is equal to new C. I have created A, B, C, 3 objects. A, Z. Z is only a variable of type A. Z is equal to A. Z dot fun. Method is executed from which object? A object. Z is equal to B. Z dot fun. Method is executed from which object? B object. Z is equal to C. Z dot fun. Method is executed from which object? C object. So dynamic polymorphism. Z is referring to which object? From there it starts executing. The same is called as dynamic method dispatch. The methods are dispatched dynamically during runtime. Dynamic polymorphism is itself called as dynamic method dispatch. Understood now? Z is referring to which object? From there it starts executing. See, Z is equal to A. Dispatch means during Z dot fun. During runtime, JVM will dispatch it from A object. Z is equal to B. Z dot fun. JVM will dispatch it from B object. Z is equal to C. Z dot fun. JVM will dispatch it from C object. Dynamically. And this cannot be decided during compilation. See, which method to execute is getting decided when now? Runtime only. It depends on the object. It can never be decided at compilation time. It can never ever be decided at compilation time, because if it was decided at compilation time, it would have executed only one method. But now you can see, here it prints inside A, here it prints inside B, here it prints inside C. Depending on the object it goes on executing. Are you clear with this? The previous I had written A is equal to new A, B is equal to new B. So this is only called as dynamic method dispatch. So working with subclass is a big subject. Are you clear? Working with subclass, writing subclass anybody will write, but working with subclass is a big subject, because you can use any variable to refer. Any variable means either superclass variable to refer to that object or subclass variable to refer to that object. If you use subclass variable to refer to that object, correct, there's an advantage. What is the advantage? You can access all the members, but you are tightly coupling. You can access all the members, but you are tightly coupling. What you are tightly coupling? Like B is equal to new B means tomorrow you don't want the implementation of B, full code you have to change to what? C is equal to new C. So B is equal to new B, advantage is there, I am not telling no. The advantage is what? You can access all the members, but you are tightly coupled with the logic of subclass. Tightly, your variable is tightly coupled with the logic of subclass. Tomorrow you want to use some other logic present in some other class, no, you can't do it. B is equal to new C will go wrong. That time you have to change completely. Understood? But the same, if a superclass variable is referring to subclass object, perfect. You can change any subclass there. So there is one disadvantage now. What is the disadvantage? You cannot access subclass members. If superclass variable refers to subclass object, you cannot access subclass members. If superclass variable refers to subclass object, you cannot access subclass members. But advantage is decoupling. What is decoupling? You don't like the implementation of B, change it to C. You don't like the implementation of C, change it to D. Are you understanding the advantages and disadvantages of these two things, clearly understand. Sorry. Yeah, I'll clear here. See the advantages and disadvantages of both. Assuming that the scenario is, this is the scenario. Clearly understand the scenario. Hierarchical, B, C, D, E, F. Hierarchical. Okay. See, I can say BB is equal to new B. What is the advantage? Means first understand the code. Subclass variable is referring to subclass object. Subclass variable is referring to subclass. Advantage is I can access all the members from subclass. All members I can access. Understood? But problem is tight coupling. Your variable, B variable, is tightly coupled with B only. B variable cannot refer to what? C. So what is the advantage? You can access all members. Disadvantage. Disadvantage is what? Your variable is tightly coupled with the object. It cannot refer to any other object. Means it's your variable is tightly coupled with the object means tightly coupled with the implementation. That's what we say. Okay, advantage A, can access all members of subclass. Yes or no? Disadvantage, D I'll write. Okay, variable is tightly coupled with object. Correct? Yes or no? Okay. Now the second condition, A is equal to new B. A is equal to new B. Correct. So here advantage is what? Decoupling. Means the disadvantage here you can take one more word, tight coupling. What is the disadvantage of this? Tight coupling. Now here advantage is what? Decoupling. Means loose coupling. Decoupling is only called as, that is tight coupling, this is loose coupling. You know coupling, no? Binding. Okay. Coupling means binding. Decoupling means we can change. This is the advantage. Okay. Any subclass implementation. We can change any subclass implementation. Disadvantage is what? We can access only superclass members. Only superclass members and not what? Subclass members. Because what members you can access depends on what? Type of variable. Clear? Advantage and disadvantage of both. So you decide when you create a subclass object whether you'll refer it with superclass variable or subclass variable. You decide. You are your decision taker. You want tight coupling, go with that. Sometimes you will want to access all the members. That time what you do? Subclass variable you do. Sometimes you want dynamic polymorphism. That time you do what? Superclass variable to subclass object. Clear? Any questions here? Now any questions? So I have to type and show you now. Clear? Very important concept. It will build. If you understand all this only, you'll understand the next topic. Which one? Abstract class interface. Those data types, if you want to understand, clearly get all these points. Shall I clear this? Changing means understood, no advantage. New B, new C, new D, new E, anything you can change. Because this is hierarchy. I can change A, B, C, D anyway. New C also you can change, new D also, new E also. What you want you change. Tomorrow more classes come. Change that. Understood? Okay, take some notes on dynamic polymorphism. Then I'll continue typing the program. What is the notes? See this. A superclass, get this point clearly. Yesterday I gave you this till half. Okay, but now it will continue. A superclass reference variable can refer to what? Subclass object. But what members can be accessed from the subclass object depends on the type of superclass reference variable. But if the methods are overridden, it always depends on the type of subclass object the superclass reference variable is referring to. Understood? The superclass variable is referring to which subclass object? It depends on that. This concept is only called as dynamic polymorphism. Next, to achieve dynamic polymorphism, following rules must be followed. What you will do? Step 1. The method must be overriding. Step 2. Subclass object must be assigned to superclass reference variable. To achieve dynamic polymorphism, you should do this. Next, finally, the rule followed is, see this. When a subclass object is assigned to superclass reference variable, the superclass reference will call subclass overridden method. Are you following it? Finally, it's becoming clear. Now I have to prove it what? With what? Examples? I have to prove now. This is the concept. Understood? I have to prove it with examples now. Next examples, whatever you see will be teaching you this particular concept itself. Clear? Is it clear? Okay, so these points you can understand. Understood? This is what is dynamic polymorphism. Very tough subject, but I am teaching you like cake. Understood? Honey cake, you know, no? I am teaching you like that. In fact, dynamic polymorphism is one of the toughest subjects which many people cannot teach. And I am giving you plenty of examples to make you understand dynamic polymorphism now. Clear? Fine. Next, let's start typing. First, we'll learn it with two classes. First, learn it with two classes, means simple inheritance. Then you can go to hierarchical, more. And again, you can write on method here, fun. You know how to work with A object now? I didn't save it only. What is the method, class name will give? Dynamic polymorphism. Yeah, you know how to work with A object, man. There is no issue with A, but still I show it to you. Work more with addresses today, it will become clear. Value of A is compile. Okay, sorry, you can call the methods. Compiles, executes. There's, sorry, inside A M1. Yeah, inside A M1, inside A fun. We don't have any difficulty. Working with a class or working with a subclass doesn't make any difference. Sorry, working with a class or working with a superclass doesn't make any difference. Now see, I'll write a subclass. Class B extends A. So I'll have M2 here and I'll override fun. Correct now? Done? Any questions here? Okay, now we'll work with B object also. See, this is tight coupling. B is equal to new B is tight coupling. Understood? If I say B dot M1, I can access subclass member. Notice P dot M2, I can access all the subclass members. But just see how you work with subclass object using subclass reference variable. Correct now? Correct now? And if you want, you can print the address. Done? I think I change. Yeah. B.M1. It's executing from where? Superclass. M2 from class B. Fun from subclass. Getting it now? Okay, that's how you are getting the output. Okay, then yeah, this is okay, but we'll see this. A is equal to B works now. One second, we'll come to that later. So I understood all this. What I'll do is I'll comment off this one now. See here, what was I doing? I was using subclass variable to refer to subclass object. Now I'll make the change here. A is equal to new B. Yes or no? Yeah, now we'll see. A.M1, A.Fun. Let's see the output here. Are you clear with this? This is what is dynamic polymorphism. We are going to a very simple program. New B. So fun is executed from B class. Carefully see that. But if I change it to A, which object is created? A object, and it is executed from A. Just a small change. B means it will execute from B. A means it will execute from A. Are you following it now? So okay, let's do like let it, and we'll make it as B only. At the same time, I'll say A.M2. Error when? Compilation time. Fun it is executing from subclass. So when it compiles, it checks can I access fun with A. It can access. It will compile it off. But during runtime, it will search from bottom. Understood? It will search from the bottom. When it compiles, compiler will be checking can I access that member. Okay. Yes, M1 also can be accessed. Fun also can be accessed. M2 cannot be accessed. Error. So now if I comment it, it will compile. But during runtime, it will be checking from bottom only. So what members can be accessed is checked by compiler. Which one gets accessed is decided by JVM. Which one gets accessed is decided by JVM. It looks from the bottom class, if not upper class, if not upper class, like that it goes. Clear? It will never depend on the type of variable. Any variable can refer to any object provided they are in hierarchy. Means they are in inheritance. Therefore any variable can refer to any object provided they are following inheritance. If they are related, you can do this. If they are unrelated, you can't do. A is equal to new B is error when? See this. Error no. B is not extending A no. Error. So rule is what? B should, if you want to say A is equal to new B, B should be a subclass of A. This is the rule. Okay. So all this you understood now. A.M2 why it is error, clear? Compiler checks. Okay. What is that? Huh? Extends A. Okay. A.M2 is error now because you cannot access it. Okay. More things we'll see. We'll see A is equal to new. Okay, first be clear with this basics. B is equal to new B. All this is okay. So this will execute now. Perfectly it will execute. And A is referring to here. A object. This is one A object. B is referring to what? B object. But all the code is getting executed. Now, address you saw. Correct? Now you say A is equal to B. Now A is referring to which object? B object. If you want to print value of A, what it prints you see. Earlier it was printing what? One address. But now it will print which address C. But it is possible. Superclass variable can refer to subclass. This assignment operator is very powerful operator, man. 1000 times I tell you. Assignment operator is a very powerful operator. Right hand side value is taken and given to the variable to the left hand side. Always you should see right hand side what value. And then you should check what is there on left hand side. This I taught you in the basics of Java programming. Understood? So now see, this will work. You can give the reference value of subclass object to superclass variable. Can you see the value of A now? Last line. Earlier value of A is this. B was this. Now A is this. Same. Yes or no? Okay. But the reverse is not true. B is equal to A is error because subclass variable cannot hold the reference of superclass object. Subclass reference variable cannot store the reference value of superclass object. See error, compilation time only. First be clear with all these basics. Yesterday I had covered all this. If you don't type and come, these problems will start off. You work and come, these are very clear concepts now. Are you clear? Okay, fine. This is done now. So we saw it to 2 levels. Yeah. So fine. Now what I'll do is, okay, here only I'll modify. We'll see dynamic polymorphism now. Okay, let this remain. Yeah, we'll write which one now? Class C extends A I'll do. We're going with one more level now. Class C is extending what? Not B, A. We are having M3 inside C, M3 inside C, fun. Are you clear? Now AA is equal to new A, BB is equal, BB is equal to new B. On the top it should be. This you leave. Now we'll say C is equal to new C. Here also tight coupling. See, I'm first showing you how to work with C object. C dot M1, C dot M2, M3, C dot fun. If you want, you can see the address of C also. All will be having different addresses. So here again see, superclass variable is referring to superclass object, subclass variable is referring to subclass object, subclass variable is referring to subclass object. Means all are correct. So here you don't have any questions. All this is okay. Inside A M1, A fun, that is okay. But when you create the B object, M1 is from A, M2 is from B, fun is from B. B means fun is from B. But when I create a C object, M1 is from A, M3 is from C, and the fun is from C. This is how it happens. Clear? So now I can say, forget all that now. So again we can see this. AA is equal to, now see the decoupling I'll show you. See, AA is equal to new B. Now which fun gets executed? B object. See, inside B fun. But the same if I say C, which object gets executed? Which method gets executed? C. This itself is dynamic polymorphism. Now which object has got created? C. Okay. We'll see it more clearly now. AA is equal to new A. Fine. So I created all the 3 objects, and then what I'll do is, see, this will work. A dot M2. Fine. This is error. Yeah, we have, now let us check. Yeah, it's compiling. Now the dynamic method dispatch will see now, or dynamic polymorphism. See here, dynamic polymorphism. AZ is equal to null. Understood? Z is equal to A. Value of Z is. And I'll comment all this, in fact, because it will be confusing for us. So many output will come out. Here also I'll comment. 1 second. I'll comment C also. Okay, AZ. Z is equal to A. Value of C is, value of A is. Z is plus Z. Z dot fun. Then Z is equal to B. Z dot fun. Correct? Huh? Okay, we'll see this one also. Z is equal to, when assigned A. Value of Z when A assigned. I'll give it like that. Z is equal to B when B assigned. Z is equal to C. Z dot fun. So concentrate on this output clearly now. This is the code what you are going to see now. Clear? Huh? I have only created the object. A is equal to new A, BB is equal to new B, C is equal to new C, and we are doing this. See, first A, B, C, three objects are created. First, see this code. Here I have created objects and I am printing the address. Clear? So after that, see what is the output. So first the three objects are created. A, B, C. One second. After the three objects are created, see now, second. Yeah. So then we are printing the value when A is assigned. Z is referring to A now. What address it's printing? A's address, and it prints inside A. Now I'll assign the value of B. So now value of B is what? Z is what? B's value. Now it will print inside B. Now I'll assign the value of C. So what is the value of C now? C object, and it will print the method from C. So this is dynamic polymorphism. Clear? So Z is referring to which object, that method starts execution. Clear this? Anyway, I think this is easy for you. You're all from computer science, I think, no? Very easy, no? Java? Because you're CS. Correct, huh? Yeah. Anyway, any questions here? Clear this? Understood dynamic polymorphism? Document? What it tells? To achieve dynamic polymorphism, following rules must be followed. The method must be, there must be method overriding. Subclass object must be assigned to superclass variable. Lastly, when a subclass object is assigned to superclass reference variable, the superclass reference will call subclass overrider method. Clear? Decoupling. Understood? And one more example I'll show you now from your college days. Let's go back to little to your college days. Okay, because if I don't teach you some college example, you'll feel bored. Let us go back to it. Now you'll only laugh. I will not laugh. Understood? So I clear this now? What a simple example we'll take. Any questions here? Let's show dynamic polymorphism. One more example for what? Dynamic polymorphism. Animal. I'll take class. Then what? Dog. Then what? Cat. Then what? Lion. Anything you want to take. Simple example. So this is hierarchical now. So class, animal. The common features we keep it into the superclass. Subclass always contains what? Specialization, and superclass always contains generalization. Class animal. Void. Void eat. Correct? SOP. Animal is eating. Correct? Okay. Void. Sound. SOP. Animal is making sound. Yes. Now we can see class dog extends what? Animal. Class dog is extending what? Animal. Specialization. So what is required for your class? You can apply it here. So what will I do? I'll override only sound. Only one change I want. Dog is SOP. Dog is barking. Correct? Then again class cat extends animal. All are extending animal. Void sound. SOP. Cat says meow. Correct? Same way class lion extends animal. Void sound. SOP. Lion is roaring. Correct? Every day ABCD. Let's go to the zoo today. Correct? Okay. Because if you go to zoo, little refreshing, no? Yes or no? Oh lion, oh cat, oh dog. Let's see. Okay, see this now. Animal A is equal to new dog. A dot eat, leave it. But check now. A dot sound. Now see what happens. The one from dog executes. I don't want dog. I like cat. Change. Whatever you want to change. Understood? Only one place will change now. Cat. Finished. You don't want cat, you want lion. Because you are great. Change. That's it. This is dynamic polymorphism. One more example. More examples you'll understand clearly. Yeah? So you change your subclass, the logic from subclass starts executing. You want me to draw and show now? Understood now? Yes or no? Full happy now? At last on college example. But did they teach this? No, they cannot teach. I know very well. Because dynamic polymorphism cannot be taught by normal person. It can be only taught by professionals. Very tough subject. I am not professional, you are professional. I am teaching to professionals. Correct? Huh? Understood? Any questions here? Dynamic polymorphism? If you say lion object gets created, you know the story, no? Dog means which object gets created? What it will have? Sound and eat and sound. Plus what it will have? One more sound. So this is dog object. So when you create the dog object, remember these many members are there. Eat sound from superclass and one more sound from subclass. But superclass variable is referring to this. So it will execute from subclass only. You call eat, first it will check in subclass, doesn't find superclass. A.sound it will execute from subclass. You change it to what? Cat. Cat object gets created. Now sound from there gets executed. You change to lion. It will execute from subclass. But eat is executed from superclass. Dynamic polymorphism. So this is what is decoupling. Decoupling means you are not tightly coupling your variable with your logic. You should not tightly couple your variable with logic. Means both scenarios will come. Sometimes you want tight coupling. Sometimes you want loose coupling. Loose coupling is nothing but dynamic polymorphism. Okay, if you want loose coupling, superclass variable to subclass object. Tight coupling means subclass variable to subclass object. Clear? This is dynamic polymorphism. I'll give more examples, more you're going to see, and you'll understand this very clearly. You don't have to worry about this. Clear? Shall I clear all this? Enough of zoo, huh? We'll go to Brindavan Gardens now again. Zoo, Mysore. KRS will come. Lovely flowers I'll show you. Next, again we'll go back to overriding. Overriding will not leave you, again it continues. That's only Brindavan Garden, it's very big. Understood? Any questions here? Shall I clear? Yes, we'll revisit overriding again. You understood dynamic polymorphism? We'll revisit overriding again and we'll summarize some points. Yeah, first we'll see this. See now, there are few, still now we saw overriding, but there are some methods which cannot be overridden. Okay, or before that, yeah, 1 second. First, so methods can be overridden, yes? Now I'll talk one more topic. Variables cannot be overridden. Java does not support variable overriding. We'll see this first. Okay, Java does not support variable overriding. Well, I think variables will go next. We'll go variables next. Just hold a second. Examples I'll give for that. Okay. Okay, we'll go with something like in Java what all cannot be, some methods cannot be overridden. Some methods. Let's see what happens. What are they? Void M1 SOP inside AM1. We'll complete off methods first, then we'll see variables. See, class B extends A. Yes, the question is about overriding now. So focus on fun only. Fun only you focus. See this now. If I make my fun method as private, I cannot override fun in subclass. This is error. Compilation error only it will give you. Understood? It gives you a compilation error. Private methods cannot be overridden. There are some restrictions in overriding now. You cannot override all the methods. So private methods cannot be overridden. Why? Question. Yes, sir? So private belongs to class. Private methods are not inherited. Only what is inherited you can override. Understood why you can't override private methods? Private methods are not, because private belongs to what? Class. Only one class. They cannot be accessed outside the class. So what you inherit, that you can override. Understood? So private methods cannot be overridden. Done. Next. Means doesn't mean that you, okay, next. We'll see. So private methods, I'll be showing you the examples. I'll be showing you clearly with examples itself. That's one concept now. Next concept. If I make my method as final, again, see, final is one more keyword which I'll be taking next topic. I'll be taking next topic, final. Okay, just I'm introducing you here. Final is a keyword in Java. Private is also on keyword, final is also on keyword. Okay. Final, what happens? If you make the method as final, final stops modification of the method. Final is used for stopping modification of the method. Actually, that's the way it works. Okay, it's a modifier. If you go and check the list of keywords, I have classified it as modifier. So final method stops modification of the method. Modification of a method means what? Overriding only, no? Modification of a method means actually what? Overriding only. So final method stops method overriding. Means you, end of the day, again what? Summary, you cannot override final methods. You cannot override final methods. Understood? So which one will you use now? If you don't want to override, which one will you use? Private or final? Final you have to use. If you really don't want to override, then make the method as final. Understood? So if you do not want to override, don't make it as private. Private is used for some other purpose. What? For not allowing the member to be accessed outside the class. Understood? Private has got some other behavior, but private methods cannot be overridden. But if I make my method as final, I can access it outside now. So making a method as final, it will allow you to access outside, but it stops overriding. So private, what it will do? It will not allow you to access outside. Understood? So behaviors are different. You should know when to make private, when to make final. Anyway, a detailed subject is there on these two things. I'll be taking later. Just I'm introducing this. I'm not completing this. Just I have to give you some document. Just I'm making you understand what private methods cannot be overridden. Final methods cannot be overridden. Reason why private methods are not overridden is they are not inherited. Reason why final methods cannot be overridden is it stops overriding. It stops overriding. The reasons are different. Private methods cannot be overridden because they are not inherited and they belong to class. They belong to class. Okay. And which one? Final methods cannot be overridden because I'm making it as final because I don't want anybody to modify my method. Understood? Last thing, one more. Static methods also cannot be overridden. I'll give you an example for all this now. Just wait. Static method. You try to compile, you'll get error. You try to compile now. You try to override it in subclass. You'll get error. Understood? So now, A is means you try to compile. You'll give error. Are you clear with this? So static methods also cannot be overridden. Okay. But this is going to give you error. But if I make here also static, it will compile. It will compile. Understood? If you don't write static in the bottom class, it will give you error. But if you write, it will not give you error, it will compile. Now let's see. Static is little bit confusing. It will take you one day time for understanding. But let's see this. A is equal to new A. A dot fun. Understood? A dot fun. It will execute from where? Means it will A dot fun and A dot m1. It will execute from where? Class A only. It prints inside A. Sorry, inside A. Yeah, inside A fun. B is equal to new B. B dot fun. Can you guess from where it will print? Inside B fun. But it looks like you are overriding. It is not overriding. This concept can be really understood here. Where you know? Here it looks you are overriding. When you see the code and all, it looks like overriding. Okay, if I say A is equal to new B, and now if I say A dot fun, can you guess from where it will print? A class, not from B class. So this one confusing thing what you'll have, which will be cleared by tomorrow. Understood? Reason is what? It is picking from the class. See, static members belong to class. Instance members belong to object. Understood? Static members belong to class. Instance members belong to object. Understood? So instance members belong to object. So when you call A.fun, it will pick from the class this time. You remove static both the places. It will execute from B. So that clearly shows static method is not supporting what? Dynamic polymorphism. Static methods do not support what? Dynamic polymorphism, and you cannot override. Static methods cannot be overridden. Reason is they belong to class. These topics I will revisit later. Understood? These topics I am going to revisit later. Which one? Private, final and static I will be revisiting later. So static methods cannot be overridden because they belong to class. Instance methods, see, overriding is a concept related to objects. Criteria for overriding is what? Object. Remember that first. Criteria for overriding is always object. And criteria for static member is what? Class. So here it is not bothering only. A.fun means it will pick from A class. Understood? Or see here, in this example only I will show you first. A is equal to new A, B is equal to new B. I will say A is equal to B. Till now what did I tell you? A.fun, from where it executes? B, no? But it will print from A. This is one more way. You can check. Static methods cannot be overridden. It is speaking from class. See, criteria for overriding is object. Understood? So that's why only instance methods can be overridden. Static methods cannot be overridden. Only instance methods. Okay, this is one way to check. A is equal to new B. Yes, this also you can see. A.fun. It will print from superclass 1, not from subclass. Yeah? So these are the things you have to understand now. Overriding is a big topic. I am telling you, warning you. Work hard on inheritance. Simply dog extends animal, animal extends dog. That is not inheritance. That's what you have learnt in colleges. Understood? Huge subject. And you are seeing now what high level of abstraction you are achieving with what? Dynamic polymorphism and all that. Clear? Okay, we'll see this with examples now. Which one? I'll code, compile and show you this. So static and these things cannot be executed now. Static, private and final methods cannot be overridden. There are reasons. Static, final, one more is what? Private. See, class A, class fun. I am just concentrating on only one method, fun method. Don't bother about adding extra method now. Okay, first, assuming that there is one class called as what now? A. Okay, so all this will work. But by chance, if I make my method as private, my superclass method has been made as what? Private. Now I am trying to do here what? Overriding now. I am trying to override or not? Yes, so this will not allow. See, I am trying to override now. Okay, see, control 1. Allowing. Okay, should not allow. Okay, here it gives error. But end of that it will not allow you to override. It's not giving error at that time, but it will give you error at runtime. Fine, say this. Fun has private access in a dot fun. Understood? Private methods cannot be overridden because they are not inherited. Remember, only what you inherit can be overridden. Clear? Okay, done. So next is final. Okay, so again I'll comment this. B, fun in B cannot override fun in A. Overridden method is final. Different error. There it was giving access problem, here it is giving you override. It cannot be modified. Okay, I'll be talking final tomorrow itself, next class. Okay, then you'll understand. We'll detail and we'll discuss about final. Lastly, static. Okay, static now. Say I'll compile. It gives me error. Understood? Static methods cannot be overridden. Then next, I'll make this also as static. Now very interesting. It will compile. Both if you make static, it will compile. Now let's see. So now AA is equal to new AA. This it will work. I'm not telling no, but it is speaking from the class actually. Understood? B is equal to, you know how to access static members, no? You can access the static members with variable names, no? That's how it's working. So it is thinking you are accessing from A. It is thinking you are accessing from B class. So it is speaking from the class. But the same if I comment all this. Okay, let this remain. Okay, I'll say A is equal to B, and I'll tell A dot fun. Now see this. This is dynamic polymorphism, no? Yes or no? See, it will not support now. It will print from, I'm calling here, I will not call all this. We created two objects. A is referring to subclass. Inside A fun. So it's not printing from the B object because overriding is related to instance methods, not static methods. Understood? You cannot override static methods. Done? So this is how it happens. Then next, okay, or you can say one more way. I'll comment all this. One more way. Because see why it, okay, one second. Why it is printing from class A? Because means why it's printing inside A? It's speaking from the class A. Variable dot fun. How do you access static member? You can access with variable name dot member, no. So it's speaking from the class. And you see, you are seeing here very clearly it is not supporting dynamic polymorphism. Understood? So that's why static methods cannot be overridden. You can't override it. Or one more way you can try. The other way you can try is even this one. In a simple way you can try. AA is equal to new B. You are creating which object? B object. But again it will pick from what? Class A. Clear? So these are the three methods which you can't override. Understood? Next, I'll take variables. See this. Here only I'll show you variables. Int x is equal to 10. I'll remove okay, one second. So one second, variable, I'll come back. See, A is equal to new B, A dot from where it is executing? Class A. You remove static and say it will print from class B. Understood? It will print from class B. Clear? Okay, now we'll go to variables. Int x is equal to 10. What it is? Int x is equal to 20. Fine. Okay, variables cannot be overridden. Now there's a conflict with variables now. There's a conflict with variables. Yes. So now see, in above x there is 10, in below x there is 20. I'm hard coding, don't bother. Okay, but see this. A is equal to new A. SOP A dot x I'll print. Understood? And we'll see this. BB is equal to new B. We are working with variables now. Don't think about methods. Just see this. I'm just showing you variables cannot be variable overriding is not supported in Java. So when you create the B object, how many X are there? First understand that concept. When you create A object, there are one X which is initialized to 10. Valid? Huh? When you create B object, how many X will be there? 2. One in superclass, one in subclass. We are hard coding there. Understood? We are hard coding. Fine. This is the case. Now, correct. Now when you say B.X, it will print from what? Local class. This is clear now? When you are working with conflicted members, what happens? Preference is given to local one. So B.X, even though there are 2 X in that, it will print 20. Understood? Now I'll say, see this carefully, A is equal to B. Done? See, all these are SCJP questions. Now I'll print value of X in A is, what do you think it will print? Superclass variable is referring to what now? Now A is referring to, earlier A was referring to superclass object. Now A is referring to this one. A.X, what it will print? 10. It will get from superclass here. So this is one way how you can, till now I was telling you, when you create the subclass object, it is never possible to access the member of variable. B.X always it was getting from what? Subclass itself. And if you want to work with this X, you have to use what? Super only in subclass. But if you do this, if your superclass variable refers to subclass object, and if you access A.X, it is accessible. X is printing what? 10. X is printing 10 now, because it is referring to B. It is referring to B, but it will pick from class A. So that clearly shows it is not supporting overriding or dynamic polymorphism. If anything which is executed from subclass is overriding, anything which is executed from superclass is not overriding. That's what static methods cannot be overridden. Okay, variables cannot be overridden. Static method was printing from what? Superclass. Okay, variable is printing from what? Superclass. Anything which is executing depending on the type of object is called as overriding. Anything which is executed depending on the type of object is called as overriding or dynamic polymorphism. Clear? Okay, so static methods, no overriding. Variables, no overriding. Even though there are 2x, are you getting the diagram there now? Is the diagram clear to you? A object was created, hard-coded value. Simply I hard-coded. If you want to give different value. Okay, if you want to initialize this with 1. If you want, you can initialize this 5 and 6. A.X, directly you can initialize. Or however you want to initialize. Now first A.X will print you 1 if it is initialized to 1. If you say A is equal to B, and if you have initialized to this, A.X will print you 5. You initialize this to 1 and you initialize this to 5. First it will print what? SOP A.X. 1 it will print. That will very clearly show you. Okay. Then you say A is equal to B. A.X it will print what? 5 it will print. Very clearly you can see. Clear this? Different address. Address will be different. Clear? Okay. So still almost all we are coming end to overriding, but still more topics are there in overriding. Okay, almost all done, but 2 big topics are there which I will cover later. Shall I clear all this now? Yes. Now we will see what are the 2 types of polymorphism supported by which are there in Java. Okay. Let me see, in OOPS there is one subject called as polymorphism now. Is polymorphism there in Java or OOPS? OOPS. Java is supporting it or giving one mechanism to support it. Okay. In polymorphism there are 2 types of polymorphism. First you understand this point, compile time. First you should be clear about this. In polymorphism there are 2 types of polymorphism. Compile time polymorphism. This is related to OOPS, man. This is not related to Java. Okay, one more is runtime polymorphism. Now, how does Java support compile time polymorphism? Question is that. It supports that with the help of method overloading. This is how Java supports it. Understood? And how does Java support runtime polymorphism? With the help of method overriding. This is how it is Done. First of all, what is compile time polymorphism? Compile time polymorphism means which method to execute is decided at compilation time. Runtime polymorphism means, first if you ask me what is compile time polymorphism, here which method to execute is decided at compilation time. Here which method to execute is decided at runtime. That's the first difference. If you want to do compile time polymorphism, do overloading. Means if you want the method to be binded at compilation time, okay, if you want the method to be binded at compilation time, do method overloading. It will bind the method during compilation time itself. But you want the binding to happen at runtime. Like example, AA is equal to new B, AA is equal to new C, AA is equal to, AA is equal to new A, BB is equal to new B, CC is equal to new C, Z is equal to A, Z dot fun, Z is equal to B, Z dot fun, Z is equal to C, Z dot fun. So here you want binding when? Runtime. So sometimes you want the methods to be binded at compilation time. Sometimes you want the methods to be binded at runtime. So that time you do method overriding. So what you want, depending on that, Java is giving you the support for programming. See the support for programming. Problem we are developers are having problem. Sometimes we'll need compile time solutions. Sometimes we need runtime solutions. Why do you need runtime solutions? Why do you need runtime solutions? To achieve what? Dynamic polymorphism. See this, we need runtime polymorphism. Z is equal to A, Z dot fun, Z is equal to B, Z dot fun, Z is equal to C, Z dot fun. So I want the support of runtime here, because if it is decided at compilation time, it will execute only one method, but I want the support at runtime. So how does Java support runtime polymorphism? With the help of method overriding. Understood? What is compile time polymorphism first? Which method to execute is decided at compilation time. Here runtime polymorphism, which method to execute? Runtime. Okay, runtime, JVM will decide. Fine. Now what is method overloading? What is method overloading? Having the same method name with different parameters is called as overloading. How do you do overloading now? Having multiple methods with same name but different parameters. Parameters means what? Type, order, number. Three things will come into picture: type, order and number. So that is called as overloading. Okay, what is overloading means? Understood now? Having multiple methods with the same name but different type of parameters is called as overloading. And why are you overloading? To achieve compile time polymorphism. To achieve this. Fine. What is overriding now? Having everything same. Means name, return type, parameter, everything same is called as overriding. Understood? Now why do you do overriding? To achieve dynamic polymorphism. Understood? To achieve it you will do this. Next, here overloading can be done for instance and static methods. Remember that. You can overload instance and static methods. You can override only what? Instance methods. Overloading is possible for both. Understood? Overriding for this. Next, this is also called as static polymorphism, because the method to be executed is decided at compilation time. This is known as what? Dynamic polymorphism. Are you getting it now? These are the differences between overloading and overriding. Then next point. This is also known as static binding. Means which method to execute is binded at the compilation time. Here, this is also known as what? Means sorry, not static binding, early binding. We call it as early binding. Which method to execute is decided at the early stage. Understood? Here it is called as late binding. See, late binding means which method to execute is decided when here? Last moment. Z is equal to B, Z dot fun. Now it will decide to execute from B. It binds. Z is equal to C, Z dot fun. Now it decides to execute from C. It binds. Understood? This is early binding and late binding. Now criteria. On what grounds is overloaded method decided? Okay. Number of parameters, order of parameters, data type of parameter. Correct? Huh? Data type of parameter is the criteria. But return type does not play a role. No return type. No return type doesn't play a role in what? Correct now? So what is the criteria for overriding now? Object. Yes. The criteria for overriding is type of object. Now why do you do overloading? Next question. When functionality is same. When functionality is same, you understanding now what is functionality? Logic is same means depending it will change only based on parameters. When functionality is similar, sorry, not same, I'll tell. When you want to write, when similar functionality is required. When similar functionality is required, but change in parameters. Understood? Why do you override? To add or change functionality. Understood? Overriding is always done for adding or to add. I'll make it simple. To add or change functionality. So this is how they have designed it. Very clear. Java is very clear in what it is giving. There's no confusion here. To add or change functionality. And lastly, this is also known as DMD. DMD means what? Dynamic Method Dispatch. But you don't have an alternate word there. Where? There's nothing like static method dispatch. Means methods will not be dispatched whenever they want statically. Understood? So here there is no word. For everything I have written an alternate. See that? Like opposites I have written. Compile time, runtime, overloading, overriding, overload instance. You can overload what? Instance and static. But you can override only instance. Static, dynamic, early binding, late binding, criteria. Criteria is what? Number, order, data type of parameter. Here criteria is what? Yeah, this is very crucial. Criteria is very crucial. Okay. Then why do you do overloading? When similar functionality is required. Why do you do overriding? To add or change functionality. Very clear it is. What support they are giving to you is very clear. Are you clear? And finally, what is polymorphism? One name, many forms. Clear? Now polymorphism is over. Understood? So, but end of the day, polymorphism is helping you to achieve what? Reusability, avoiding complexity only now. You know why you override, why you overload now. But why they are giving you support for polymorphism? Why is OOPS giving support for polymorphism? Or what is the intention of polymorphism? Reuse, avoid complexity. Clear? Reuse and avoid complexity. Shall I clear all this? Shall I clear all this? Fine. Lastly, we'll see on document. You write it there. And that completes overriding. Small topics are there which I'll cover later. Blink, okay. Shall I clear all this now? Got the difference between overloading and overriding? Shall I clear? See, there are a few points. You can write it down there. Just we'll finalize what is overriding now. Yeah. See this. Implementing the superclass method in the subclass with same name, same signature. Signature means what? What do you mean by signature? Number, order and type of parameter. Understood? And same return type is called what? Method overriding. What is overriding means? Now I am giving you all the notes. Now you can clearly understand. Before I had given you wouldn't have understood. So okay, fine. Criterion means it's singular. Singular. Criteria means plural. Okay. Criterion for method overriding is the type of subclass object which is created. That's the criteria. The superclass method will be hidden. The superclass method will be hidden and it should be invoked explicitly if required from overridden method of subclass. Next point, method overriding is done for what reason? To add or change functionality to the method present in superclass. Method overriding helps for achieving what? Dynamic polymorphism, also known as dynamic method dispatch. Clear? Now only instance methods can be overridden. Clear? Now only inherited methods can be overridden. Instance and inherited methods. Now which is a non-inherited method? Private. So example, see, private is a non-inherited method. Final, stops, modification, they are different. Okay, so private, static and final methods cannot be overridden. These are keywords. What I mark in yellow, they are keywords. Now static methods cannot be overridden because static method is bound with class, but instance method is bound with objects. Next, one more point, static methods do not support what? Dynamic polymorphism. That's one more point. Now private methods cannot be overridden because they are not inherited. Now final methods, private methods cannot be inherited because they are not overridden. Final methods cannot be overridden because if a method is marked as final, it cannot be overridden. Final stops overriding or modification of a method. Final I'll take in detail later. Okay, now one more point. Constructors are not inherited. That's why you can't override what? Constructor also. That's one way you can tell. Another way of seeing it is what? Java supports only what? Method overriding, but not constructor overriding. You cannot override a constructor also because you know the class name will be different now. By chance, if you class box, in box weight, if I write box, what will happen? It is not treated as constructor. It is treated as what? Method. The rule of constructor is what? The class name and the method name should be same. So that's what? Constructor cannot be overloaded. See this class box. So here if I write, it is constructor. So in the subclass, class box weight extends box, what should I write? If I write box, it's treated as a method. It's not, because the method name and class name should be same. That's the rule for constructor. Understood? So you cannot override. There are many reasons, many answers for that. You just understand constructors cannot be overridden. That's it. This is one of the reason. One more reason. Okay, this is one more reason, because the class name and method name will be different, because you know constructor is a special method which has the same name as class name. Okay, so one reason is why you can't override constructor. Method name and class name will be different. One more reason is constructors are not inherited into subclass. Another reason is Java supports only method overriding but not constructor overriding. Clear? One more, Java does not support what? Variable overriding also. It does not support two overriding. One constructor, other one is variable. It supports overriding of only method, instance methods, that too. That is one more point you have to think. It supports overriding of instance methods, not static methods also. Yeah? Next, fine. Now see if the now these 2 points I'll be covering very later to you. Now you'll not understand this because I have to give you examples for this. You write it down because all the points of overriding will come into one place only. It just says, say there is something called as access specifier in Java which I have to cover. After I cover that, then I'll tell you. Okay. So supposingly in the superclass, if I am having an access specifier, just I'll tell you theoretically. With example, you'll be seeing it later. Understood? Theoretically, I'll tell you. Supposingly class A is there, fun is there in the superclass. So we override this in subclass. Class B extends A, we override. This is only overriding. There are, okay, fun. See, there are 4 types of access specifier. There are 4 types: private, default, protected, public. We'll be discussing this later. That's why I can't give you examples, but you write it down. If your method in the superclass is final, if the method in superclass is private, you can't override only. Ruled out. Overriding is ruled out here. Understood? If your method is marked as private in the superclass, you cannot override. If you don't write anything, it is called default. It is called as default. I can override default methods. Okay, then you are overriding default methods. You can have an equal access or higher access. Higher access means don't write anything here, or you can make it as protected, or you can make it as public. Three options. So if it is private, you cannot override. It is default, it can be default or protected or public, means it can have an equal or higher access. Lastly, protected means it can be either protected or public, means in the superclass if it is protected, then in subclass it can be either protected or it can be public. Two options, both you can do, both. But in the superclass if it is public, then subclass should be mandate, means equal or higher. Understood? So this is one more point. After I teach you access specifiers, I will cover this topic, but you can write off your notes. Clear this? So if your superclass method is having one access specifier, okay, if it is having access, till now you are saying without access specifier, then in the subclass you should have an equal or higher access. Equal or higher means hierarchy, means higher means this is how it goes. Mrs. How will I draw the arrow mark? Downside will draw. So this is higher, this is less. Private, no overriding. Default, protected, public. Protected means protected and public. Public means only public. Clear? Shall I clear this? It's documented there. You can write it. Clear? Once again, let the projector switch on. So there are many rules to follow for doing overriding. All these rules you should be very clear. See this. See, if the superclass method is having an access specifier, then the overridden method of the subclass should have an equal or higher access specifier. Means access specifier in superclass, if it is private you cannot override. If it is default, it can be default, protected, public. If it is protected, only protected or public. If it is public, only public. Just write this table. Detailed I will be telling you later about all this when I teach you access specifiers. Next, there is one note which very difficult to explain now. Because it deals with packages. I will be explaining this also later. So what methods you can override, that also you should be very clear. Simply you cannot override everything. Okay. So, just write it down. I will be explaining it later. A subclass within the same package of superclass can override any superclass method that is not declared or private or final in the same package. Just write it down. Don't bother. I will be explaining it later. Okay. A subclass in a different package can only override the non-final. One is in the same package, but the topic here is classes in same package, classes in different package. I have not covered packages, that's why I cannot explain you this. Just write it down, don't bother. Okay, that's one part of overriding. And one more major rule of overriding is there. This is also one major rule. This is related to exception handling. Understood? Exception handling, write it. Don't bother what it is, because I have not taught you exception handling. So all the points of overriding will come under one roof. Two topics I have to cover. One is access specifier, the other one is exception handling. Rest all points I have covered. Understood? Two topics I have to cover with example. Theoretically I have done. Okay. But two more topics I have to cover with which are now examples. Understood now which are the two topics? One is with access specifier and the other one is with exception handling. That's it. Rest all examples I have given you. All examples I have given you. All examples now. Private, static, all this I have given. Clear? Okay. This completes overriding and dynamic polymorphism.